So find this time y equals 4x squared plus 3 from first principle. So just like the last one, choose 2 points on the curve, P and Q, join them up with a chord. P is my general point, x here, right? And then of course my y will be this. And then what we do then is we move a distance h across and we get to a point Q on the curve. So my x value will be x plus h. To work out what my y value, you just put it in there, don't you? So basically, your x value now is x plus h, so we've got to square it, of course. There's also a 4 in front of it, okay? So we get that, okay? And then, of course, you got a plus 3, right? So we'll work out the gradient of the chord PQ, okay? Here's my x1, y1, here's my x2, y2. So that will equal then, okay? So y2, which is all of this, okay? Take away my y1 then, which is this. Now remember now, because I want to take away y1, as it says there, okay, take away all of this, so put it in a bracket, because that minus needs to apply to all of it, and that's going to be all over x2, which is x plus h, take away then x1, which is x. So on the bottom, nicely, the x's go, yeah, they cancel. On the top, what you'll find is, of course, you've got a 4 there, so keep that as it is, but you've got this x plus h all squared. We need to write that bracket out twice, don't we? Okay, and then plus 3, and then we've got minus, then applies to both terms in there, so minus 4x squared, and then minus 3. And what's nice is, of course, the 3, my minus 3 cancels, and that will be all over h. So what I do is keep the 4 as it is, right? And then just work out this FOIL here with this double bracket. Of course, we'll need another bracket because this 4 needs to apply to it as well. But if we do FOIL here, first we get x squared, outers we get xh, inners we get xh, last we get h squared. And then the 3's have gone, and this is minus 4x squared all over h. So this will equal then, if you times this bracket out, so you get 4x squared, and I times by that. Now notice, of course, remember here I've got xh and xh, well that gives me 2xh, doesn't it, when I put them together, 2xh, times it by the 4, so I get 8xh, okay, and then 4 times h squared is 4h squared minus 4x squared, all over h. Now the 4x squareds cancel, okay, and I'm just left with this, and you'll notice on the top you can take out a h, you can factorize out a h, so you can have 8x there, which will give me 8xh when I times, and then to get 4h squared I need 4h in this bracket, times by the h, give me 4h squared. Well, the reason why we factorize is because it will cancel with the h's on the bottom, alright? So you left them with the gradient of PQ is equal to 8x plus 4h. Now, of course, I don't want the gradient of PQ as such. I want the gradient of the tangent, don't I, of P. Okay, but if we think about it, if we let Q get closer and closer to P, in other words, if we reduce h, that chord gets ever more looking like that tangent. Okay, in fact, if we let h go to 0, it'll become that tangent. So we just literally said we've got to use this terminology. We say, look, dy dx is equal to the limit as h goes to 0. So we're limiting h to 0 of this, and of course 4h becomes 0, so you're just left with 8x, which is what we'd expect for our answer there. Part B then, it says write down the gradient of the tangent to the curve y equals 4x squared plus 3 at the point minus 3, 39. Well, of course, we know dy dx is equal to 8x, okay, because we've just worked it out there, but you can work it out anyway, can't you? Here, as we get, because we know it's going to be 8x, bring the 2 down to get 8x, and at that point, so we can say, look, at minus 339, we can work out what dy dx is. Okay, so remember, dy dx is the gradient function, yeah, just remember that, right? It's the gradient function, and if we sub in values, we can work out what the gradient is. Okay, so in this case, I don't need the 39, I'm not interested in that, it's irrelevant for us because this is the value which we're going to sub in, isn't it, to dy dx. So we're going to put minus 3 in, okay, and then we get out 8 times minus 3 is minus 24. So that's the gradient there. The gradient of the tangent is minus 24 because you put minus 3, the x value in, you worked out what dy dx is, and we've got the answer. With C then, it says find the x coordinate of the point on the curve y equals 4x squared plus 3 where the gradient of the tangent of the curve is 4. Now notice they're telling us that gradient of the tangent. Well, we've got the gradient function here, haven't we? dy dx is equal to 8x. Okay, we were interested in when the gradient is 4. In other words, when dy dx is equal to 4. Okay, that's what we're interested in, when the gradient of the tangent. So when this gradient function is equal to 4, okay, because that's what the gradient is, it's 4. So dy dx, in this case, is 8x. So put it equal to 4, and then quite simply you can get your x value out. Okay, so take the 8 over, so we get 4 divided by 8. Okay, that's what the x coordinate will be, 4 over 8. Of course, simplify that then to be a half. You can check in your calculator if you want, but it is a half, isn't it? And then you're done. We've got it. We've got the x coordinate.